Okay, welcome to the module or the little video on the data handling, the statistics. So without further ado, let's kick off. As we've done previously, we'll start off by looking at the two formulae we get given. This one over here is for the average of some numbers, what we call the mean. And really what it says just add them up and divide by how many there are. We'll talk now a little bit later about the F as the frequency, the number of times that data item occurs times the actual data item. And just you just add up all the data items and divide by how many there are. And then this formula here gives us our variance, which is the square of standard deviation, but we'll talk about that in quite a bit more detail just now. So just to start off with some terminology, and you need to learn this stuff. First up, the mode is the most commonly occurring data item. Sometimes there might be two that occur the same number, then you list them both. The mean we've spoken about already, it's the numerical average, and the symbol for the mean is X with a little bar over the top of it. The second quartile, Q2, is called the median, and that's the middle data item in a ranked list. So all of these ones are what we call measures of central tendency. That's not all that important. And then we have sort of a few measures of spread, range, how spread out the data is. So range is the biggest minus the smallest. Ranked data is data which is sorted. The first quartile is the Q1 is the data item which occurs 1/4 of the way through ranked data. The third quartile is the data item which occurs 3/4 of the way through ranked data. And then the variance and the standard deviation are a measure of the spread of the data. And I'll talk about that in more detail. Just remember that the variance is the square of the standard deviation. So the standard deviation is the square root of the variance. Okay, let's remind ourselves about this idea of a 5-number summary. And what we do is we take the number of terms we've got and we add 1 and we divide by 4. And that gives us the positions for our quartiles. So, for example, over here we've got 27 numbers. I think I'm right in saying. I'm just going to count them to check. Indeed, 27 numbers. So 27 plus 1 gives us 28 over 4. That means that the first quartile will be in the 7th position. The median, or quartile 2, will be in the 14th. So we take that 7 and double it, in the 14th position. And the third quartile, we take the 7 and multiply it by 3, and we get the 21st position. So 1, 2, 3, 4, 5, 6, 7. 15 will be our first quartile. 8, 9, 10, 11, 12, 13, 14. 46 will be our second quartile, or our median. 15, 16, 17, 18, 19, 20, 21. 66 will be our third quartile. Right, so if we then look at so the 5-number summary is the smallest number, which is 1, followed by the 3 quartiles in order, 15, 46, 66, followed by the largest number, which is 90. So this over here is what we call our 5-number summary. And it's those numbers that we use to draw a box and whisker plot. So there's 1, there's 15. 15, the first quartile is the bottom edge of the box, the left-hand edge of the box. 46 is the median. So this is Q1. This is the minimum. This is Q2. Q3, which is 66. And then the maximum value, which is 90. Two measures of spread that are quite important are what we call the range and the interquartile range. So the range is just the biggest minus the smallest. So the range would be 90 minus 1, or 89. The interquartile range is the third quartile minus the first quartile. So 66 minus 15. So the interquartile range would be 51. One of the things that we need to be able to do is establish whether data is symmetrical or skewed left or right. So there's two bits of terminology that we use for left and right skewed. Right skewed, we talk about the data being positively skewed. and left skewed, we talk about the data being negatively skewed. So there are two pictures for each of these. The bottom ones are the box and whisker plots that we've just spoken about. And basically what happens is that the median will be kind of in the middle of the box for symmetrical data. And one would expect the whiskers to be of similar lengths. With positively skewed data, the data to the right above the median, in other words, bigger than the median, is more spread out than the data to the left. It's not that there's more data, it's just that it's more spread out. Obviously, there's exactly the same number of data items that are bigger than the median as there are smaller than the median, but the ones that are bigger than the median are more spread out. We say that the data is positively skewed. And notice how the corresponding kind of histogram looks. So it's actually sort of across to the left. There's a bump across to the left as opposed to a bump across to the right. So it's really important that one's able to identify where the data is positively or negatively skewed. Basically, if it's positively skewed or skewed right, then there's more data. The spread of data is bigger to the right of the median, and vice versa for negatively skewed. Okay, one of the things that sometimes gets asked is testing whether an item is an outlier. Now, there's a few different definitions of this, but one of the common ones, so they'll either give you this one, or they might expect you to know this one, but a data item is considered an outlier if it exceeds the third quartile by more than 1.5 times the interquartile range, or if it is less than the first quartile by that amount. So, for example, suppose Q1 is 40 and Q3 is 50. Then the interquartile range is 10, and 1.5 times the interquartile range would obviously be 15. So anything that's 40 minus 15 is 25. Anything less than 25 would be considered an outlier here, or anything that is bigger than 15 above Q3, in other words, bigger than 65. Those would be considered outliers. Sometimes they would be excluded from the data set because they're considered sort of freakish or anomalies. Right, one of the things that we need to be good at is calculating standard deviation. And there are two ways of doing it. One is understanding how the formula works, and the second is using a calculator. And I'm going to show you both, and I'm going to show you why you need to know both. All right, so if you look at this formula gives us variance. And what it says basically for every item, we take away the mean, we square the result, and we add all of them up, and then we divide by how many there are. So we basically find an average of the difference between the mean and every data item squared. We add those up and divide it out, so we get an average. Right, and that gives us the variance. So the first thing in calculating standard deviation, we would need to find the mean. So, for example, if I had these four numbers here, 2 and 5 is 7, and 7 is 14, 24, the mean is going to be 24 divided by 4, or 6. Right, then what I do is I take each data item, and I work out what is that data item, 2 minus the mean, 5 minus the mean, 7 minus the mean, and 10 minus the mean. Right, those obviously come to -4, -1, 1, and 4. Now, interestingly, if one averaged those out at the moment, we'd get 0 because the positive ones and the negative ones would kind of cancel each other out. That is why we do a squaring over here. So we now square each of these numbers. So we get 16, 1, 1, and 16. We add them up and we get 34. And then we divide by how many there are. So 34 divided by 4. Right, now 34 over 4, I think, is 8.5. And that is our variance, right? So the standard deviation would be the square root of 8.5. Right, let's have a look at how we would check this out on a calculator. Right, so we go mode, stat, and we're going for one variable stats. You'll notice I've got the frequency mode turned on my calculator. That's a good idea, and I'll show you how to turn that on just now. All right, but we're going to put in our data items, 2, 5, 7, and 10. We then press all clear, and we go shift, stat, and we're going for var, which are the variables about those data items. The calculator gives us three options that we're going to use. The first one is n, how many data items there are. The second one is x bar, that's the mean, which we've already worked out to be 6, so we won't bother to confirm that. And the third one is the standard deviation, and we always use this one as opposed to this one, which is also a standard deviation, but for a different application. So we use number 3, right? And we get 2,914. Now, so that's the standard deviation, and I'm hoping that that's the square root of 8.5. If I square that result, we see that I get 8.5. So it is, in fact, indeed correct. So a lot of people will say, well, why on earth would one bother to calculate standard deviation this long way if one's calculator can do it? And examiners try to make up questions that make sure you actually understand what's going on with standard deviation. So let's have a look at 2 examples that I've made up. Right. So here's an example. We're not given the raw data. John calculates the standard deviation of 5 numbers to be the square root of 44. And he finds a scrap of paper from his calculation. And the question is, what number was here if these numbers, which we don't actually know the original data, had a standard deviation of the square root of 44, and there were 5 of them. So now remember, if the standard deviation is root 44, then obviously the variance, which is what the formula we get on the data sheet, the variance will be 44, right? Now there are 5 numbers. That means that the sum of the squares, in other words, this of our numbers must have been, of our numbers minus the mean all squared, that must have been 220. Because once we divide it by 5, we get 44. So these here have to add up to 220, right? And so that enables me to work out A. And so I've got 89, I think, 89, 90. All right, so I think I've got 211 over here, I think. And I hope I'm right, in which case A must be 9. Okay, so that is correct. And the only way that we can do this question is, in fact, understanding the principle. Let's have a look at an even maybe a slightly higher order, level 1. So here are the maths marks for a class of 23 boys, and they have a mean of 73% and a standard deviation of 10. Daniel's mark of 67% and Tim's mark of 79% are removed. What will the new standard deviation be? Now, this is quite a kind of one's got to think a little bit about this, but because obviously if marks are removed, the mean might change. But in fact, if one have a look at it, these 2 boys average out at the mean. Daniel's mark is actually 6% below the mean, and Tim's mark is 6% above the mean. So their marks being removed will not affect the mean. So the mean is still 73%, even when there are only 21 marks. All right. Now, what we knew is that the standard deviation was 10, all right, which means that the variance is 100, which means that when we added up all the numbers from 1 to 23, each one minus the mean, okay, we actually know that the mean is 23 squared, we would have got 2,300. And the reason we need to get 2,300 is that when we divide by 23, it being n, we get 100, and then when we square root it, we get our standard deviation of 10. Right. Now, if we only take this up to from 1 to 21, then what we've got, all right, we're going to get our 2,300, but we now need to minus Daniel's mark minus the mean, and Tim's mark minus the mean. So Daniel's mark is 67, minus the mean is 73, and 79 minus 73. This one comes to negative 6 squared, or 36, and this one comes to positive 6 squared. So we need to take, from 2300, we need to take 72 away, and that leaves us with 2281. Sorry, it doesn't at all. It leaves us with 2228. All right, 2228, but that I now need to divide by 21, the new value of n. So what in fact I get is I get that the new standard deviation is going to be 2228 over 21, and that would be the variance. So I then need to square root it. We work all of that out, and we get about 10,3. So the standard deviations increased slightly. Right, let's take a look at interpreting standard deviation. All that standard deviation is, it's a measure of spread. So for example here, all three of these distributions of data, the green, the red, and the purple, have got the same mean, right? These are sort of normal distributions. They're symmetrical about the mean, right? But in fact, the green one has got a lower standard deviation, right? So for example, if we call this one sigma 1, that one's standard deviation sigma 2 and sigma 3, then sigma 1 is actually the smallest standard deviation. The data is the most sort of, or the least spread away from the mean. Sigma 2, the next smallest standard deviation, and sigma 3, the biggest standard deviation. The data is more spread out, right? So as a general rule, if one goes one standard deviation either side of the mean, we include 67% of the data. If we go two standard deviations, we include 95% of the data. And if we go three standard deviations, we include just short of 100% of the data. These numbers are worth remembering. Okay, next we're going to talk about group data, right? So what I've got here is I've got some actual data, and what I've done, just to illustrate the point, is that I've actually, there's the actual data, right? And we can actually work out, for this actual data, we can work out if we type in these actual numbers, we actually get a mean of 39.03. Sometimes we're not given the actual data. We're just given the grouped data. So what we've got here is we've got the fact that 9 people achieved marks between 20 and 30 out of 60. 6 people achieved marks between 30 and 40. 7 people achieved marks between 40 and 50. And 8 people achieved marks between 50 and 60. Now we are asked to estimate the mean of this data, right? And what we do is we assume that these 9 people who achieved marks between 20 and 30, we assume that they averaged out at the midpoint. So in other words, we say 9 people got a mark of 25, right? We could be quite far out in our actual calculation, but as we'll see, it's actually not too bad an estimate, right? Likewise, these 6 people, we assume that they achieved on average the middle point of the interval. So we get all the midpoints of the intervals, and now we're going to go to our calculator, all right, and we are going to work these out. I just want to show you how to put your calculator into frequency mode, because it's really useful to be able to do that. All right, so what one does, one goes shift mode, down arrow, 4, and then make sure that frequency is turned on. Right, now when I go into mode stat, and I'm still talking about one variable statistics here, so 1, notice I've got a frequency button. So the midpoint was 25, the next midpoint was 35, the next midpoint was 45, and the last midpoint was 55. And now I go up and I put in the frequency. 9 people, 6 people, 7 people, 8 people, right? I'm going to press all clear, and I'm going to go shift stat, and I'm going to go 4 for variables. And first up, let's just check the number of data items. If I press 1, you'll see that, okay, something's gone wrong here. 9 and 6 is 15. I should have got 30 data items. I've obviously made a mistake with the data. I'm going to go Shift Stat and actually look at the data that I put in. Yeah, indeed, I pressed an 8 rather than a 9. Okay, so that was a useful little check. Okay, so if I go Shift Stat 4 for the variables and I go 1, I get 30 data items, which is what I was hoping for. Shift Stat 4, I can now also get the mean or the standard deviation, but those will be estimates. And the reason they're estimates is that we're not working with the original data, we're working with this assumption that they averaged the midpoints. So I'm going to go with the mean now, and then we'll notice that I get an answer of 39.67 compared with the actual answer of 39.03. Right, so this is an estimate as opposed to the actual answer. Right, here, just to finish off on this, we see why, in fact, we see how our formula is working here. So it's the frequency times the value, so 9 times 25 plus 6 times 35 plus 7 times 45 plus 8 times 55, all divided by n, and we get our answer. Okay, still working with group data. Sometimes we ask you plot what's called a cumulative frequency curve. Just the important thing to remember here is that we start off, so we've got our frequencies. In the column next door, we have what's called the cumulative frequency. So, for example, 9 is the cumulative frequency thus far, plus 6 gives us 15. This number of 15 means that 15 people got a mark of 40 or less. Right. The last number in our cumulative frequency column is the number of data items, the total number. Okay. And that means that obviously 30 people got a mark of 60 or less. When we plot the cumulative frequency curve, we use the right-hand end of the interval and our cumulative frequency as the point to plot. So you'll notice we plot 39 and then we plot 40, 15, 50, 22. Right. The normal shape, and I'm not drawing this one accurately, the normal shape of one of these cumulative frequency curves is a kind of elongated S. And what it does do is it always, the last point that we plot is always N. We always plot the sort of the marks, the weights, the heights, whatever they are, on the horizontal axis and our cumulative frequency on the vertical axis. Right, so let's take a look now at an example of a cumulative frequency curve. And I actually want to hide something there, so I'm going to just quickly pause and we'll have a look at. Okay, sorry about that. So we've got a cumulative frequency curve that's been drawn here. We've got marks on the horizontal axis, and we've got number of students on the vertical axis. So the first question here is, what is the interquartile range? Now we've got 50 students. So 50 divided by 4 is about 12 and a half, right? So what I'm going to do is I'm going to put in at 12 and a half and at 47 and a half. So those are the positions of the quartile. Now we allow a little bit of sort of leniency in terms of exact accuracy here, all right? But 12 and a half and 47 and a half. These numbers over here, this will be Q3 and this one will be Q1. All right. The next question says, if a merit mark will go to the top 10%. Now the top 10%, obviously out of 50 students, would be from 45 to 50. So if we just have a look at them, all right, if we go from 45, we read off and we get a mark of about 83%. We normally are asked to show where we're going to read off our answers. And then the last question, if 35% is a pass mark, what percentage of the students failed? So let's just have a look. 35%. Now I'm looking over here at 35%. And we see that we get about 5. All right. So just to answer these questions then, all right, the interquartile range will be 73 minus 45, which is about 25. If a merit mark will go to the top 10%, remember the top 10% are the last 5 pupils, those there, we read off about 83%. And then lastly, if 35% is the pass mark, what percentage of the students failed? Well, 5 out of 50, so about 10%. That's really important skills that you can read off these cumulative frequency curves.